Hey, what's up, everyone? I just wanted to show you very quickly today why do you want to have a really good output filter after your DAC. In this particular case, we are using, as you can see, ADAU1701, which is a very nice audio DSP processor, and it has integrated DACs for your output. And in this case, I'm using them instead of the digital output, and really I wanted to show you how does the audio signal look like after it goes out of the DACs, and why do they recommend to have a nice good analog filter, active filter at the output. So this here is the my implementation, so it's slightly different than the recommended one, but it's not massively different. It works in my circuit and some values are rationalized, so it does the job, and I'll show you on the scope how well it does the job, and that's gonna give you really the feeling of why'd you want one. So this is how the audio signal, so this is a 1 kilohertz test sine wave. So you can see this is how it looks directly out of the DAC. So no filtering at all, and you get, quite a fuzzy line there. It's not a clean line for sure. And this is what you get out of the output. Look at that. What a difference, right? So all of that fuzziness has been cleaned with this output filter, and if we zoom right in, you might get just a little bit better feel for what it is. Look at that difference, right? So if you don't have the output filter like so, then all of this fuzziness is effectively noise, audio noise, and it can start to be quite a big problem in your audio circuit once you start amplifying that noise, which is sort of ends up being quite wide bandwidth, and that's obviously gonna mess up your audio signal. So yeah, be sure to have a nice good filter after the DAC so that all of this switching noise is cut out from your desired audio signal. Now, we looked at a 1 kilohertz signal, but what happens if we look at a 20 kilohertz signal? And this is where it becomes even more interesting, because this is what we have now on the output. So, it's a nice, decently clean sine wave, but look at what the DAC is outputting. And this is crazy, isn't it? This is the same filter, same section, straight out of the output of the DAC. This is what we get at 20 kilohertz. And then after the filter, look at this beautiful sine wave. So from that to go to this is quite remarkable, and it's really interesting to see kind of how DAC approximates the 20 kilohertz wave. This is some significant steps, quite a lot of jitter, obviously. Basically crazy approximation. I don't think you would really expect, I for sure didn't, but this is what you get. But if you do the filtering correctly, you can get a really nice sine wave anyway. So it's sort of one of those, you have to trust the process. And yeah, this is why you want to have a really good filter on the output. So thanks for watching, and catch you next time. Bye.